Here's a relatively quick, pretty simple magnetic flux, magnetic circuit question. There is 0.1 amps there are 0.1 amps of current going through a coil with 400 turns. So we don't care what the coil looks like right now. I'm just going to draw it like this. Here's a basic coil. I know that that makes that means that there is a you know uh, a force that is going to establish magnetic flux lines. That force is relative to the number of turns. Number of turns, it looks like it's 400 turns. And there's some current going through here. It looks like the current is equal to 0.10 amps. And it says, what is the MMF? Well, then there's going to be this much of MMF. FM, or you can say equals MMF, it doesn't matter, is equal to the number of turns times the current. If there are more turns, then you're going to establish more flux. Right here, there are 400 turns. If there is more current going through it, then you are going to establish more lines of flux. But in this case, you are going to establish, I believe, 40 amps of magnetomotive force, and I'm carrying along that T term. Next question, what is the reluctance of this circuit? If the flux is 250 microwebers. So 250 microwebers, micro means moving a decimal place 6 times to the left. So I would call that flux equals 0.000250 Webers. We can express it like that, or we can put that into some significant digits. I can say, I can keep it as 250 times 10 to the negative 6 Weber. Either way, there's there's 3 significant digits. Either way, there's 3 significant digits here, and there's 3 significant digits here. But we do have to remember that the reluctance is related to the force over the magnetic flux in this relationship, which is most commonly written as Fm equals Rm times flux, which means it's the flux that's established, and it's sort of related to the however much flux is established depends on how reluctant or less reluctant the material is. At any rate, we would substitute this in, and I am making this a 3 significant digit problem. And I'm taking this 40 from my from part A of this question. 250 times 10 to the negative 6 Weber. And that would be 1.60 times 10 to the 5 amp turns per Weber would be the answer.